Hello Year 6 and welcome to Tuesday the 19th of May's maths video. Today we are continuing to look at ratio. Now before we get into the challenge answers, I'm hoping some of you, the very observant of you, noticed that in yesterday's video I referred to the symbol which separates ratios out as a semicolon. That was obviously a mistake and I meant a colon, so I'm very sorry about that. Okay, let's go into today's video. These are your challenge answers. Let's have a look. For every red cube, there are 8 blue cubes. That's obviously false because, as we can see here, for every one red cube, we actually have 4 blue cubes. For every 4 blue cubes, there is 1 red cube. This is true. What's happened here is that the ratio has been reversed, and that's fine as long as you say clearly there's 4 blue cubes to 1 red cube. You could not look at this ratio and you could not say that for every 1 red cube there is 4 blue cubes. You could not say it in that way. You would have to say it in that way. 1 red cube, 4 blue cubes, 4 blue cubes, 1 red cube. You have to read the ratio as it is presented. The third one, for every 3 red cubes there would be 12 blue cubes. Well, how could we work that out? We could use our scaling up. So if we look at our ratio, we've got 1 red to 4 blue, and it's telling me that for every 3 red, there's going to be 12 blue. What do I multiply by 1 to get to 3? Well, that's 3. 4 times 3 is 12, which makes this one true. This one here, for every 16 cubes, 4 would be red and 12 would be blue. Let's write out that ratio. So it's telling me that 4 would be red and 12 would be blue. Now, if you've already wrote this here, you can quite clearly see that this ratio is not going to be correct. But if we hadn't got that, just rubbed out that one. If we haven't got that, then how could you work that out? Well, 1 times 4 is 4. 4 times 4 is 16, not 12. So our ratio would be 4 red to 16 blue, which means this one is false. For every 20 cubes, 4 would be red and 16 would be blue. Now, if you've worked out this one, you can see I've actually already got the answer. I've multiplied them both by 4. For every 4, for the 4 red, I have 16 blue. 4 red 16 is 20 cubes in total. Then let's have a look at the other challenge question that you had. So we've got these tiles here and they've been laid in this following pattern. And it's telling us that she's got 16 red tiles and 20 yellow tiles remaining. Is that possible to use up all of those tiles without there being any left over? So let's look at the original ratio. I've got 2 red to 3 yellow. And it's asking me here, well, if I've got the rest remaining, is that possible? Now, if we have a look here, as it says, for every 2 red tiles, there are 3 yellow. So we've wrote out the ratio. If she would continue the pattern, she will need 16 red tiles and 24 yellow. So how have they worked that out? Well, if you have a look, 16 red tiles, what's happened here? Well, the ratio has been scaled up. 2 times 8 is 16. 3 times 8 is 24, not 20. So as it's explaining here, they need 16 red tiles and 24 yellow tiles. She can't continue the pattern without there being tiles left over. And this is because 20 is not a multiple of 3, as we've just seen here when we've multiplied both numbers by 8. So let's carry on with our ratio. First one is super easy. Match the ratio of plums to pears to the correct picture. So this should take you about 10 seconds to do. If we have a look, this first one has already been done for us, conveniently in the correct place. Here I have 4 to 1, so that one would match up over here. Oh, that's a messy line. 1, sorry, because the plum comes first. 1 to 3 goes there. And the last one would be matched there. Very simple, matching that up there. Yesterday we looked at scaling up and scaling down ratios. Can any of those ratios be scaled down? No. Why can't they be scaled down? Because they're already in their simplest form. 5 to 2, 1 to 3, 5 to 1, 4 to 1. They do not share a common factor, and therefore you cannot divide them. Could they be scaled up? Of course. How do we scale up? We make sure that we times all of the ratios by the same number. So here we could times them both by 2. We could double our ratio. 5 times 2 is 10. 2 times 2 is 4. Have a go at doubling all of these ratios. Let's have a look at this one. So we're doubling our ratios. We're timesing them both by 2. 1 times 2 is 2. 3 times 2 is 6. 5 times 2 is 10. 1 times 2 is 2. 4 times 2 is 8. 1 times 2 is 2. So we should be confident now on scaling a ratio down and scaling a ratio up. The ratios might be smaller or bigger, but they are always what? They are always equivalent. So today we're going to take that knowledge and we are putting it into some word problems. The ratio of ducks to geese in a pond is 2 to 5. There are 10 ducks. How many geese are there? If you think you can have a go at this, then pause the video and we'll go through it. So I'm going to write out the ratio. I've got 2 ducks to 5 geese. And I'm going to make a little note here. D and G, and that obviously stands for ducks and geese. Now it's telling me that in this particular pond, there are 10 ducks. And I need to work out how many geese there are. What's happened to my ratio? It's been scaled up, so we repeat the process. What do I multiply by 2 to get to 10? Well, multiply it by 5. Whatever we multiplied by this ratio, we have to do the same to this ratio. 5 times 5, 25. So therefore there are 25 geese. I don't think I'd like to be near that pond if there was 25 geese there. You might have a question which would say, how many ducks and geese are there in total? How would we work that out? We'd add these two up together. 35 ducks and geese in total. And we could apply this question, how we've just done this, to any number of ducks. Let's say instead we have got, let's say, 24 ducks. There we go. This time we've got 24 ducks. Pause the video and see if you can work out, if there's 24 ducks, how many geese would there be? So if we have a look this time, I've been told I've got 24 ducks. Let's repeat the process. What do I multiply by 2 to get 24? Well, I multiply it by 12. So 5 times 12 is 60. That pond sounds even scarier. There's 60 geese this time. And there we have it. So now you're taking your knowledge of scaling up and down with ratios and applying them to word problems. Here we have your challenges for today, children. Pause the video, have a go at them, and we'll go through them tomorrow. Thank you for listening.